In this question, it is given that the power radiated by a black body is P and its radiate maximum energy at a wavelength lambda naught. If the temperature of black body is now changed so that its radiate maximum energy at a wavelength that is 3 by 4 lambda naught, the power radiated by it becomes Np, the value of Ns. So we know that according to Wien's displacement law, the wavelength at which the maximum power radiated is inversely proportional to the value of temperature, or you can write the value of lambda 2 divided by lambda 1 is equal to T1 divided by T2. So with respect to this, we can find out the relation between their temperature. That is, let's say the lambda 2 in question is given as something but 3 lambda naught divided by 4, and lambda 1 is given as lambda naught, and take it as the initial temperature was T naught, and the final temperature is taken as T2. So we can find out the value of T2 over here in terms of T naught. So the value of T2 will be equal to 4 times of T naught divided by 3. So we can say that the temperature is basically increased by 4 by 3 times. Then we can find out the relation for this power radiated. We know that this power radiated, or according to that Stephen's law, dq by dt is equal to E sigma A, temperature of object raised to 4. So this power is directly proportional to T raised to 4. So we can write the value of P2 divided by P1 is equal to nothing but T2 divided by T1 raised to 4. So power radiated in the second situation divided by power radiated in the first situation, let's say P, is equal to T2 is nothing but 4 by 3 times of T naught, and T1 is equal to T naught raised to 4. So we can write the value of P2 is equal to P into 4 by 3 raised to 4. So you can write the value of P2 is equal to P into 4 raised to 4 is nothing but 256, and 3 raised to 4 is nothing but 81. So the value of N will be equal to nothing but 256 divided by 81.